So last time we talked about addition and subtracting matrices. Today we're going to continue by talking about how we can multiply matrices. Now when we talk about multiplying matrices, there are actually two types of multiplication we can talk about. First is what we call scalar multiplication, when you multiply a number times a matrix. And second is what we call matrix multiplication, when you multiply a matrix by another matrix. So we're going to start off by talking about a scalar product. So as I mentioned, a scalar product of a matrix is when you have a scalar k, some real number, and a matrix X. The product is going to be k times x, where that matrix, that resulting matrix, is where each of the elements within the X matrix is multiplied by k. So as an example, if you look at the first one here, we have calculate -5 times A, where A is the matrix 3, 4, 0, -1. So this is what we call a scalar product because -5 is a scalar, it's some constant k, that we're going to multiply the matrix by. So in order to find -5 times A, I'm simply going to multiply each element within the matrix A by -5. So this is going to be -15, -20, 0, and 5. And that's it for multiplying a scalar times a matrix. Now, on the other hand, when we talk about matrix multiplication, we're talking about when we are multiplying two matrices together. So let's say you have a matrix A, and it is an m by n matrix, and you have a matrix B, which is an n by k matrix. Now notice that they are different sizes, but also notice that the number of columns in one matches with the number of rows in the other. In order to find the element in the ith row and the jth column of the resulting product matrix A times B, you would have to multiply each element in the ith row of A by the corresponding element in the jth column of B, and then you would add all those products together. The resulting matrix is your product matrix AB, and the size of that matrix is going to be an m by k matrix. Now notice how m is the number of rows in A, and k is the number of columns in B. I'm going to take a look at an example to see how this works. So say you have A and B as given here. You'll notice that A is a 2 by 3 matrix, and B is a 3 by 1 matrix. Now we can multiply these because the number of columns in A matches with the number of rows in B. So we can multiply these, and our resulting matrix is going to be of size 2 by 1. So it's the number of rows in A by the number of columns in B. Now, in order to show you how to find the product of these two matrices, I'm going to line up the matrices so that A is on the left and B is up on top, and then the resulting matrix that we're going to find, that 2 by 1 matrix, is going to be this matrix right here. Now in order to find what those elements are, as a 2 by 1 matrix, that means there are two elements in the matrix. In order to find this, we are going to have to do some multiplication and then some addition. So we're going to take this number here times this number here. So we're at the first row, first element, and the first column, first element, and we're going to multiply those two together. Then you take the second element in the first row and multiply it by the second element in the first column. And then you do the same with the -1 and the 6. So the third element in the first row and the third element in the first column. And then once you've multiplied all of those together, you're going to add them. So 2 times 1 plus 3 times 8 plus -1 times 6. So we have 2 plus 24 plus -6, which is equal to 20. Now we're going to do the same thing, but with the second row. So to get the second element in our 2 by 1 matrix, we're going to have to multiply the first element in the second row by the first element in the first column of the other, and so on. So we're going to do 4 times 1 plus 2 times 8 plus 2 times 6, so that's 4 plus 16 plus 12, which is equal to 32. So our resulting matrix is a 2 by 1 matrix where the elements are 20 and 32. Let's do another example. Find the product CD of matrices C and D as given. Again, notice the size of each of these matrices. We need to know the sizes because you're not always going to be able to multiply them together unless you are multiplying two matrices where the first matrix has the same number of columns as the second matrix has rows. So we have a 2 by 3 matrix and a 3 by 2 matrix. So we have 3 columns in C and 3 rows in D, so we are going to be able to multiply those two together. I'm going to line them up the same way I did in example 2. And now our resulting matrix, you can see, is going to be a 2 by 2 matrix. So now I'm going to multiply -3 times -6, 4 times 2, and 2 times 3. I'm going to add them all together. So we have 18 plus 8 plus 6, which is equal to 32. We'll do the same thing to get the next element in our 2 by 2 matrix. So here we're going to do 5 times -6, 0 times 2, 3 times 4. That's going to give us -30 plus 0 plus 12, which is equal to -18. Now we still have 2 more elements to find in our 2 by 2 matrix. So now I'm going to look at the first row in C and the second column in D. So -3 times 4 plus 4 times 3 plus 2 times -2. So we have -12 plus 12 plus -4. That's equal to -4. And then to find our last element, we're going to look at our second row of C and our second column of D. So 5 times 4, 0 times 3, and 4 times -2. That's equal to 20 plus 0 plus -8, which is equal to 12. So that is our 2 by 2 matrix that we get as a product, multiplying C and D. Okay, so we've already seen this, but just to summarize, the product of two matrices A and B can only be found if the number of columns of A is the same as the number of rows of B. So for example, if A is a 2 by 2 matrix and B is a 2 by 4 matrix, then this, as long as these two numbers, the 2 and the 2 in this case, match up, then you're going to be able to multiply those two together. The other two numbers, the outer numbers, you can say, are going to give you the size of the product. So AB is going to be a 2 by 4 matrix. Now, if you had, say, the same two matrices A and B, but instead of doing A times B, you did B times A, you'll notice this actually will not work because the number of columns in B does not match the number of rows in A. So since those don't match, you won't be able to find the product. So notice how in matrix multiplication, unlike multiplication in, say, any other system that you've probably seen up to this point, it is not going to be commutative. All right, example 5. So in this one, find AB and BA, given that A is this 3 by 2 matrix and B is this 2 by 3 matrix. So I'm going to line them up just like before. We're going to find AB first. And we know that our resulting matrix is going to be a 3 by 3 matrix. Okay, so the first one is going to be 1 times 1 plus -3 times 3, which is equal to -8. Next we have 1 times 7, 3 times 2 is 13, if we add them together. -2 times 1 plus 5 times 3, that's equal to 13. Next we have 0 times 1 plus 1 times -3, and that's equal to -3. Next, 0 times 7, and 1 times 2, which is 2. Next, we have 0 times negative 2 plus 1 times 5, and that's equal to 5. All right, our last column, we're looking at this negative 1 and 4, and this 1 and negative 3 to start. So negative 1 times 1 plus 4 times negative 3 is negative 13. Then we have negative 1 times 7 plus 4 times 2, and that's equal to positive 1. And then lastly, we have negative 1 times negative 2 plus 4 times 5, and that's equal to 22. And that is our resulting matrix when we multiply A times B. Now you still have to find B times A. So now instead of writing A on the left and B up on top, we're going to switch, and we're going to write B on the left and A up on top. Now you'll notice that we are able to multiply this because the number of rows in B matches the number of columns in A. However, our resulting matrix is going to be a 2 by 2 matrix. All right, so we're going to do 1 times 1 plus 7 times 0 plus negative 2 times negative 1, and that's equal to positive 3. Next, 1 times 3 plus 7 times 1 plus negative 2 times 4, and that's equal to positive 2. And then we look at the second column now here in A, and the first column in B. We have negative 3 times 1 plus 2 times 0 plus 5 times negative 1, and that's equal to negative 8. And for our last element, we have negative 3 times 3 plus 2 times 1 plus 5 times 4, and that's equal to 13. Now you'll notice that although we were able to multiply A times B and B times A, you do not get the same answer. So again, AB and BA, when we're talking about matrix multiplication, shows us the commutative property does not hold when it comes to matrix multiplication. All right, our last example. A contractor builds 3 kinds of houses, models A, B, and C, with a choice of 2 styles, Spanish and contemporary. Matrix P shows the number of each kind of house planned for a new 100-home subdivision. The amounts for each of the exterior materials depend primarily on the style of the house. These amounts are shown in matrix Q. Concrete is in cubic yards, lumber in units of 1,000 board feet, brick in thousands, and shingles in units of 100 square feet. Matrix R gives the cost in dollars for each kind of material. So you can think of each of these matrices as a sort of chart. So if you look at matrix P, it tells you there are 3 models, and it could be either a Spanish or contemporary style for each model. And so matrix P is telling you how many of each kind of house is planned for these 100 homes in this area. So it looks like, for example, that there are no Model A homes in the Spanish style that are going to be built, but there are going to be 20 Model B homes in the contemporary style. So this is really just a chart of the types of homes that are going to be built of these 100 homes. If you look at Q, we're told that Q is going to give us the amount of exterior materials that are needed for each style of home. So for example, it looks like the Spanish style would require 10, and in this case it says concrete is in cubic yards, so 10 cubic yards of concrete, whereas the contemporary style home will require 50 cubic yards of concrete. So that's what the Q matrix is telling us. And then the R matrix here is telling us the cost in dollars for each kind of material. So 20 for concrete, 180 for lumber, and so on. Now, what is it asking for? What is the total cost of these materials for each model? Well, in order to do this, we need to first find P times Q. What does P times Q tell us? It's going to show us the amount of each material that's needed for each model. So, if we multiply P times Q, now it's going to give us a new matrix, and in that matrix it's going to tell us for model A how much concrete do we need? For model B, how much concrete do we need? For model C, how much concrete do we need? And then it will tell us all the information for lumber, brick, and shingles for each model A, B, and C as well. All right, so multiplying this out, this is our matrix PQ, and this tells us that each row represents a model and each column represents a material. So for example, you can see here model A is 30 for lumber, 40 for lumber for B, and 60 for lumber for C. Now, this isn't the total cost. We haven't even factored in the cost. R is going to help us determine the cost. Well, since now we know how much of each material is needed for each type, each model type, we can then multiply this by R. And that is going to give us the cost for each model. Model A is going to cost a certain amount, Model B a certain amount, Model C a certain amount. So what this is really doing is this is having us multiply the first element in PQ by the first element in R, and then we're going to add that to the second element in the first row of PQ times the second element in R, and then add that to the next one and the next one. So by doing that, 1500 times 20 plus 30 times 180 plus 600 times 60 plus 60 times 25, we get that this is 72,900 for model A. We can do the same thing to get the cost for model B and the cost for model C. So you can see how having all this information in terms of a matrix is helpful so that we don't lose any of the cost of each material, or for each specific model how much of each material you need, but then you're also able to utilize those matrices and by multiplication find the actual cost for each model.